This presentation will be given by Takahashi from Fujitsu. We at Fujitsu have, as you can see, gotten Open Chain certification in 2024. As introduced in the keynote session earlier, today we officially joined the Open SSF. Thank you. Let me introduce our team. As of the end of March 2024, Fujitsu has contributed the most patches to the Yocto Project and OSS committee. This is the agenda when many suppliers make products using embedded Linux. They use Yocto. Also, because of reasons like CRA, we think there will be more cases where suppliers give SBOM and vulnerability information like VEX with their products. In this presentation, I'll first share some background knowledge. Next, I'll talk about our idea for providing VEX and SBOM when we use Yocto. I'll also mention the current problems we have. Finally, I'll share our future work. First, I'll share some background knowledge. Let me explain about VEX. Because I don't have much time, I'll make it short. This diagram shows how VEX is used. It shows the steps from the supplier making the product to the user investigating the product's vulnerabilities. The top part shows without VEX, and the bottom part shows with VEX. Let's slide this diagram to the left. This diagram shows the subsequent process from the previous diagram. The key point here is that by using VEX, the number of vulnerabilities that users need to investigate can be reduced. Next, I'll explain Yocto in a simple way. Yocto is a tool that makes embedded Linux distributions. It uses something called recipes to make products and SBOMs. Recipes contain information such as source code URIs, vulnerability patch information, and if vulnerabilities apply. Let's talk about another important thing. In September 2023, a fantastic blog called VDR VEX, OpenVEX, and CSAF was posted on the official OpenSSF page. At the end of this blog, there is a section called Best Practices. This slide summarizes those best practices in my own way. Since this is from 2023, better ideas might come in the future. First, when releasing a product, also release the SBOM and VEX. Second, store the SBOM and use a tracing tool to get vulnerability information. Third, store the status information of the vulnerabilities. Fourth, generate a VEX each time new vulnerability information is disclosed. The important point here is that the thinking of releasing the VEX is different from the product and SBOM. Next, I'll show you how to use Yocto to do the best practices I just talked about. Just a moment, please. Sorry. Okay. This is showing the diagram. The top left shows vulnerability information services like NVD, and the left side shows Yocto. On the right side, this one, there is an OSS tool called Yocto VEX check. This tool, Yocto VEX check, is an excellent tool that bridges the gap in the VEX release things that I explained earlier. I have one note here. Right now, Yocto VEX check is still in the RFC stage. It cannot read the vulnerability status DB. Also, the VEX files it makes don't fully meet the rules of the minimum requirements for VEX by CISA in April 2023 or the VEX status. This slide shows a case where supplier release a product and new vulnerability information comes out. Because of time, I will skip explain this flow in detail. In this example, we will talk about this bold root. Release the product, find vulnerabilities, decide that the product has the vulnerabilities after checking, fix the vulnerabilities with patches, and update the product. This slide is a release product step. Run Yocto to generate the product, SPDX and CVE check JSON. Next, run Yocto VEX check. These inputs for this are vulnerability information from places like NVD, an SPDX file with OSS package information, the CVE check JSON, and the vulnerability status DB. Based on these inputs, a VEX is generated. In this way, the product SPDX and VEX are released. Let's move on to the next. A new vulnerability has come out, and NVD said that the OSS package used in the product has the vulnerability. Therefore, the supplier registers the vulnerability status as under investigation in the vulnerability status DB. Then they run Yocto VEX check and release a new VEX. Let's move on to the next step. The supplier investigated the code to see if the OSS package used in the product has a vulnerability and found that it does. Therefore, the supplier removed the vulnerability status as under investigation in the vulnerability status DB. Then they run Yocto VEX check and release a new VEX. This is the final step. The supplier applied a patch to fix the vulnerability and updated the Yocto recipe file. Then they did the same steps as in step 1 to make the product SPDX and VEX. This ends the example using the use case. I'll share the two challenges. First, discrepancies between the Yocto VEX check tool specifications and the proposed configurations. Second, consideration of methods for collecting vulnerability information. Finally, I'll share the future work. First, we want to share information with the Yocto VEX check maintainers. Second, we want to organize the product problems and bring them up with the Yocto community. That's all. Thank you.